All right, so you've learned the addition reactions for this chapter, you're applying them to molecules, and you'd come to a problem like this. You would look at the carbon chain and you'd say, oh, we have that pi bond, and that means we can have extramolecular glue that we can use to add things onto this molecule. And so we're going to do an addition reaction. What are we going to add? That's where you would look above the arrow and you'd see that there's not just a halogen here, but also a water molecule. And when those two things are combined, you would know from the reaction list that that is halohydrin formation. So you're going to be adding both a halogen and hydro, a water molecule, halohydrin formation. And so when you think about this just in terms of synthesis, you would be thinking about three things. What are you going to be adding? Where are you adding it? And how are you adding it? So what you're adding is a halogen, in this case bromine. If it were Cl2, then you would be chlorine, but it's one of the halogen atoms. And then an OH, which is ultimately coming from water. It'll add as water, and then in the mechanism you do a proton transfer to stabilize it after it adds, and that gives you an OH. So you transfer an H plus off of the water molecule, so instead of H2O, you have just HO. So that's what we're adding. Where we're adding things, because these are different, it does make a difference. And if you think about the mechanism for this reaction, which is walked through both in the lecture video and also in the videos in the bonus page for this chapter, then you'll see that the OH goes to the more substituted carbon. Also, there's no rearrangement. So that's nice. That means these two things will always add to the two carbons in the double bond. And this is anti-addition. So if one of them adds from one side, then the other has to add from the other side. And if you have a chiral center, you'll have both of those scenarios. You'll have a 50-50 mixture of those two scenarios. So that's if you have a chiral center, just watch out, you'll have a racemic mixture. That's a 50-50 mixture of the two possible enantiomers. Okay, so you see this recipe and you think, okay, halohydrin formation, and this is what goes along with it. What I'm adding, where I'm adding it, how I'm adding it. So if you take a specific molecule like this one here, you can look at those two atoms in the double bond. The one on top is primary, the one on the bottom is secondary. And so here you know the OH is going to go to the carbon that is more substituted. So that's going to be that secondary carbon here. And we erase that pi bond because we're going to use those electrons to stick these things onto these carbons in the mechanism. So that's where the OH goes. The bromine would go on the opposite position, or on the other carbon, I should say. And if we had no chiral centers, that would be the end of this problem. But we do have a chiral center, and so we have to show that that we have a racemic mixture. Now these add anti, and so it might be most useful to just draw that in, that we have, in one case, the OH is going to come toward us, and the bromine is going to go away from us. And then that's 50% of the time, and then the other half of the time, we'll have the OH going away from us and the bromine coming towards us. And so you'll have a mixture of those two products. And so for this reaction, those are the two products you would want to draw. Now technically this top carbon is not chiral, and so you don't have to draw the three-dimensional bond to that bromine, but I'm doing it here just for consistency. If you ever have a chiral center, you might as well draw all of the three-dimensional bonds. And that helps me to know that you know that it's anti also, which is nice. So that would be the product for this particular reaction. So let's take the same sort of reasoning and apply it to another carbon chain. So you'd look at this, you'd see, okay, I have a double bond in my molecule. That means I can do an addition reaction. I can use that glue, that extramolecular glue, to add something onto that carbon chain. What am I going to add? That's where you look at the recipe that's going above that arrow, and from your studying, you would know that that is halohydrin formation. So you're going to add the halogen, which in this case happens to be bromine, just one of those, and you're going to add an OH from the water. The OH is going to go to the more substituted carbon. You don't have to worry about rearrangement. They add anti to each other, the halogen and the OH, and if you have a chiral center, you have to draw both enantiomers. You're going to have a 50-50 mixture of the two, because these double bonds are flat, and so the reaction can happen with equal likelihood on either side. So we can take this molecule now, and we'll look at the two carbons in the double bond. The one on the left is tertiary, the one on the right is secondary. So the OH is going to go to the more substituted carbon. That's the tertiary one, here. We're going to erase that double bond. We're going to use those electrons to attach things in the mechanism, so the double bond won't stay there. And then the bromine will go on the other position. Now this is a ring, and on rings, it's always important to show the anti or syn addition for these. Also, you have chiral centers here, which is another reason it's important. So these add anti to each other. We're going to draw one bond coming out at us, and then the other bond would be going away because they're anti. And you're going to have a mixture of the two possible enantiomers. So you won't just have that enantiomer, you also have the one where the OH is going away and the bromine is coming out at you. And the last thing you'd want to adjust here is this tetrahedral carbon needs to have two bonds in the plane, one coming out at you and one going away. So this one on the left is just missing the bond going away, so that's how we'll draw the methyl group. And this one on the right is just missing the bond coming out at us, so that's how we'll draw the methyl group. And so those would be your two products in this reaction. So hopefully that gives you some idea of the thought process you want to go through when you're doing a one-step synthesis with halohydrin formation where they give you all the reactants.